Welcome to this video. In this video we will know more about the Sun, its layers and Aditya L-1 mission by ISRO. The Sun is the central celestial body in our solar system, a G-type main sequence star often referred to as a yellow dwarf. It boasts a staggering mass of approximately 1.989 x 1030 kilograms, dwarfing Earth by a factor of about 330,000. With a diameter of roughly 1.4 million kilometers, 870,000 miles, the Sun is over 100 times wider than our planet. This fiery sphere is primarily composed of hydrogen, constituting about 74% of its mass, and helium, which makes up around 24%, with trace amounts of heavier elements. The Sun's core is a searing inferno where hydrogen atoms undergo nuclear fusion, generating intense heat of up to 15 million degrees Celsius, 27 million degrees Fahrenheit, and radiating copious amounts of light and heat. As one moves outward from the core, the Sun's temperature decreases, with layers including the radiative and convective zones, culminating in the superheated corona. This star drives Earth's climate and sustains life through its energy output, while its solar activity, including sunspots, flares, and coronal mass ejections, can impact space weather and communication systems. The Sun is fundamental to the workings of our solar system, and its eventual transformation into a red giant in about 5 billion years will profoundly influence the fate of Earth and its neighboring planets. The Sun is a complex and layered celestial body composed of several distinct parts or regions. These regions vary in temperature, density, and composition. Here are the primary parts of the Sun, from the core outward. Core. The core is the central region of the Sun, where the most crucial processes take place. It's incredibly hot, with temperatures reaching about 15 million degrees Celsius, 27 million degrees Fahrenheit. In the core, hydrogen atoms fuse together to form helium through a process called nuclear fusion. This fusion process releases an immense amount of energy in the form of light and heat, which provides the Sun's power source. Radiative zone. Surrounding the core is the radiative zone. This region is not as hot as the core but is still extremely hot, with temperatures gradually decreasing as you move outward. Energy generated in the core travels outward through the radiative zone in the form of photons. These photons are constantly absorbed and re-emitted by the dense plasma in this region, making their journey through this zone a slow and arduous process. Convective zone. Beyond the radiative zone lies the convective zone. Here, temperatures decrease further, allowing for the movement of matter in the form of convection currents. Energy transfer in the convective zone occurs through the physical movement of hot, buoyant plasma. Hot material rises toward the surface, cools, and then sinks back down to be reheated in a continuous cycle. Photosphere. The photosphere is the visible surface of the Sun, and it is the layer from which sunlight is emitted. It appears as a bright, yellowish surface. The temperature of the photosphere is around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Sunspots, cooler regions on the photosphere, are visible here. Chromosphere. The chromosphere is a thin, reddish layer just above the photosphere. It is often seen during solar eclipses as a pinkish ring around the dark disk of the moon. Temperatures in the chromosphere increase with height, and it is home to features like spicules, prominences, and solar flares. Corona. The corona is the Sun's outermost layer, extending millions of kilometers into space. It is characterized by its extremely high temperature, reaching temperatures of several million degrees Celsius. The corona is visible during total solar eclipses as a faint, pearly white halo surrounding the sundial. It constantly releases charged particles in the solar wind, which affects space weather and can influence Earth's magnetosphere. These are the main regions or parts of the Sun, each playing a vital role in the Sun's structure, energy generation, and the phenomena we observe in the solar system. Now let's move on to ISRO's new launch to the Sun, the Aditya L-1. Aditya L-1 is a planned coronagraphy spacecraft to study the solar atmosphere, designed and developed by the Indian Space Research Organisation, ISRO, and various other Indian research institutes. It will be inserted at about 1.5 million km from Earth in a halo orbit around the L1 Lagrange point between the Earth and the Sun, where it will study the solar atmosphere, solar magnetic storms, and their impact on the environment around Earth. It is the first Indian mission dedicated to observing the Sun and is scheduled to be launched aboard a PSLV-XL launch vehicle at 11:50 HRS IST on 2nd September 2023. Mission Objectives. The major science objectives of the Aditya L-1 mission are: study of solar upper atmospheric, chromosphere and corona dynamics, study of chromospheric and coronal heating, physics of the partially ionized plasma, initiation of the coronal mass ejections and flares. Observe the in situ particle and plasma environment, providing data for the study of particle dynamics from the Sun. Physics of the solar corona and its heating mechanism. Diagnostics of the coronal and coronal loop plasma, temperature, velocity and density. Development, dynamics and origin of CMEs. Identify the sequence of processes that occur at multiple layers, chromosphere, base and extended corona, that eventually leads to solar eruptive events. Magnetic field topology and magnetic field measurements in the solar corona. Drivers for space weather, origin, composition and dynamics of solar wind.